division, what number makes this equal to 0? 2. I'm copying down my coefficients, and I'm dropping the first term below the line. It's not 4 plus 4. We drop that 4 all the way down. 2 times 4, we multiply. Negative 3 and 8 is 5. 5 times 2 is 10. 7 and 10 is 17. 17 times 2 is 34. Negative 9 and 34 is 25. Remainder constant x squared. Your answer will always be 1 degree less than your dividend. You do need to write the answer out. 4x squared plus 5x plus 17, and it's always remainder over my divisor. The answer needs to be written in this form. You can't be done right after the synthetic division. You do need to finish by writing your answer. When it's an x to the 4th problem, a little bit longer, negative 3 in the box because negative 3 makes that equal to 0. 1, negative 3, 4, negative 5, and 8. Drop that first term of 1. Negative 3 times 1 is negative 3. Negative 6. Negative 6 times negative 3 is 18. 22. 22 times negative 3 is negative 66. Negative 71. And negative 71 times negative 3 is 213. And that adds to 221. Now, when I'm done writing my answer, we have remainder constant x squared, x cubed. So it's x cubed minus 6x squared plus 22x minus 71 plus 221 over x plus 3. And that's how the answer has to be written. It has to be in that form. You can't stop here. You can't stop here. It's got to be the x cubed minus 6x squared plus 22x minus 71 plus 221 over x plus 3. Here, we always need to be aware, is a term missing. This has an x to the 4th, but no x cubed. We need the 0 in something like that as a placeholder. So 1 goes in the box because that's what makes my divisor equal to 0. And it's 2. I don't have an x cubed. That's where the 0 goes. The order of where the 0 is matters. We drop that 2. 1 times 2 is 2. 0 and 2 is 2. 2 times 1 is 2. Negative 5 and 2 is negative 3. Negative 3 times 1 is negative 3. We end up with a 5. And 5 times 1 is 5. And we end up with a negative 10 as our remainder. And my answer becomes constant, let's stop doing that in the wrong order. Sorry about that. Remainder constant x squared, x cubed. So it's 2x cubed plus 2x squared minus 3x plus 5 minus 10 over x minus 1. And quite honestly, if you wanted to check it, 1 to the 4th is 1, 1 squared is 1. 2 times 1 is 2, minus 5 times 1 is 5, 2 minus 5 is 3. 8 times 1 is 8. Negative 3 and 8 is 5. And 5 minus 15 is a negative 10. All right, that is how you can check it if you'd like. Here, 3 goes in the box because 3 makes that divisor equal to 0. And we have 2, negative 8, 5, 7, and negative 18. I drop the 2. 2 times 3 is 6. I get negative 2 when I add. Negative 2 times 3 is negative 6. I get negative 1 when I add. Negative 1 times 3 is negative 3. I get 4 when I add. 4 times 3 is 12. And I get negative 6 when I add. 2x, remainder, constant, x squared, x cubed. 2x cubed minus 2x squared minus x plus 4 minus 6 over an x minus 3. And there's our answer. All right, sum of two cubes, difference of two cubes. The sum of two cubes is this: a cubed plus b cubed equals, we need to know this, a plus b, a squared minus ab plus b squared. Same sign, different or opposite sign, and it's always positive on the back end. My a here is 3x, my b here is 5, and I'm literally plugging the numbers in. 3x plus 5. 3x quantity squared, 9x squared, minus 3x times 5 is 15x, and 5 squared is 25. There's our answer. Here, a cubed minus b cubed equals a minus b, same sign, a squared plus ab plus b squared. My a in this case is 6x, my b is 1. So it's 6x minus 1. Quantity 6x squared is 36x squared, plus a times b, 6x times 1 is 6x, plus 1 squared is simply 1. All right, when we group, right away I'm putting the first two terms in parentheses, I'm putting a plus sign down, and then I'm putting the second two terms in parentheses, and I'm keeping that middle sign with my third term. My GCF here is 2x squared. You take the lowest exponent out, and you take the highest common factor out. When I take a 2x squared out of both of these, I'm left with x minus 3, which means I better be left with x minus 3 when the GCF comes out of this, plus a 5 out, and we are left with x minus 3. And then the answer is simply putting the GCFs together in one parenthesis and keeping that common parenthesis there. You can confirm your answer by pulling this out and making sure you get the original problem back. Second one, same deal. I'm putting parentheses around my first two terms, plus, and then parentheses around my last two terms. And I'm keeping that middle sign with the third term. When I pull a GCF out, 3x comes out of here, 5x minus 9. Pull a negative 2y out of here, and I'm left with 5x minus 9. It's imperative you get the same number in each parenthesis, or same, I should say, expression in each parenthesis. And we're left with 3x minus 2y, 5x minus 9. Those are your answers. So whenever we have factoring where you have an exponent, half the exponent, and no exponent, you're going to factor normally. This is like factoring 2x squared minus x minus 15 with one major difference. I have 2x and I have x. My factors of 15 are 1 and 15, 3 and 5. I'm going to go with 3 and 5 first. Put the 3 here and the 5 here. So that gives me 6x and that gives me 5x. And I need a negative x in the middle. So that makes this negative, that makes this positive. The only difference is, if it's x to the fourth and x squared in the middle, you're always going to use this middle exponent on both variables. That's my answer. So if I did it with 6x to the sixth, it's kind of the same deal. It's really kind of the same deal here. I'm going to try 3x and 2x first. Now, 4 and 7, doesn't make much sense to use the 4 with 2, so I put the 4 and the 7 here. 21x, 8x. I can make that 13 by making this negative and this positive. The exponent I use is always the middle exponent. Just think about it. 3x cubed times 2x cubed, that's 6x to the sixth. 21x cubed minus 8x cubed, when you combine the like terms, is plus 13x cubed. it's always going to be the exponent.